So good afternoon. Today we will be learning vector multiplication. We have already seen the scalar product of vectors, and in this lesson we will see the vector product of vectors. As we discussed earlier in the last class, a vector can be multiplied with a vector and we can get either a scalar quantity or a vector quantity. When we get a scalar quantity as a product, we call it scalar product or dot product. And if A and B are two vectors and if we take the scalar product, it is represented as A dot B and it's equal to AB cos theta, where theta is the angle between vector A and vector B. Now, let us see what is meant by vector product. Vector product, as the name says, when you multiply a vector with another vector, the result will be a vector. So in vector product, you can also call it a cross product, because it is represented as, if it is vector A and vector B, A cross B, and it is equal to AB sine theta and a unit vector. Why we need a unit vector? We need a unit vector to show the direction of the cross product. So when you take the cross product or vector product of two vectors, the result is a vector which has magnitude AB sine theta, and it will also have a direction usually denoted by a unit vector n. Now, A and B are the magnitude of vector A and vector B, and theta is the angle between them. Now, how can we find the vector direction? What will be the direction of the cross product? For that, let us see a vector A, another vector B, and the angle between them is theta. When we take the cross product, you can use the right hand screw rule to find the direction of the product. For that, you have to consider a right hand screw, and if you keep it perpendicular to both A and B, and if you rotate it from A to B, the direction in which the screw advance or go forward will give you the direction of the cross product. Now, there is an easy way to do that. You can also take your right hand. Take your right hand, curl the fingers, hold the fingers in the direction of the first vector, that is A, and curl your fingers towards B along the small angle. Suppose when you say about the angle between A and B, you may consider the small angle between them, or there is a larger angle between them. So you have to consider the small angle always. It's important. So you have to consider like this. Curl your fingers and your thumb will point in the direction of the cross product. So your thumb is pointing outward. So it will be the cross product A cross B will be a vector which is directed out of the plane of this whiteboard. So it will be coming out. So that is how you can find the cross product. The magnitude is A into B into sine theta, where theta is the angle between them, and the direction can be found out using your right hand. Keep your right hand with the fingers in the direction of the first vector, curl it towards the second vector. Through the smallest angle between them, the thumb will point in the direction. Now, whatever direction we keep, suppose I have a vector here P, okay, vector P, and I have another vector Q, suppose, and I have the angle between them theta. Now, when I find P cross Q, I have to take my right hand, I have to keep the fingers in the direction of P and curl it towards Q, so you can see the thumb is pointing outwards. Now, that is outwards. Now, what if I am considering B cross A? Suppose I am considering B cross A. So, what will be the result? It will be B into A into sine theta. And what will be the direction of the unit vector? So you have to keep your fingers in the direction of B and curl it towards A. So what is the direction? It's going inwards. So when we consider A cross B and it is in outwards, we consider N as outwards, right? And when we consider B dot A, we found that it is opposite to N cap. It's inwards. So we can put it as minus N cap if we consider the outwards one. So it is inwards. So is A cross B equal to B cross A? Can you say A cross B and B cross A are equal or same? Is it same?
No.
No. Why? Is their magnitude same?
No.
The magnitude of A cross B is AB sine theta. Magnitude of B cross A is BA sine
Same.
theta, which is same, right? B and A are just numbers. So their magnitude are same. Magnitudes are same. Both of them have same magnitude, but different direction. Different or opposite direction. So when you take A cross B, you will get the same magnitude. See, A and B are just numbers. So when you take these two numbers, suppose this is 6 and this is 3. 6 into 3 is 9. Here again, 9 into, 6, 3 into 6. That is 9. See, their magnitude are same. Sine theta is same both ways. But the direction is opposite. So when you take the cross product and if you change that, you can say that their magnitude will be same, but their direction will be opposite. Or you can say A cross B is not equal to B cross A. But A cross B will be equal to minus of B cross A. Because their direction only changes, but magnitude will be the same. So what do you say about this? A cross B, B cross A. What about two numbers, two vectors, A plus B and B plus A? Are they same? A plus B and B plus A, are they same? They are same. A plus B will be equal to B plus A. And what about A dot B and B dot A? Will they be same?
Yes.
Yes. A dot B will be equal to B dot A because there is no direction. Only magnitude. A B cos theta, B A cos theta. A and B just being magnitudes or numbers. If you multiply them in either way, you will get the same number. So these two, A plus B is equal to B plus A dot B is equal to B dot A. Since they are equal, we call that commutative. So they obey commutative law, or you can say that vector addition is commutative. Scalar multiplication of vector is commutative, while vector product, vector multiplication is not commutative. It's not commutative because A cross B is not equal to B cross A, but A cross B is equal to minus of B cross A. The direction of A cross B and B cross A will be opposite to each other. Their magnitude will be the same. Now also you can note here A and B are in the plane of this whiteboard. But when we find A cross B, the direction is perpendicular to the whiteboard if it is outside. Again here, PQ are two vectors. When I take the direction of their product, P cross A, Q, P to Q. See, the direction is outward. So wherever I draw two vectors on this plane, their product will be perpendicular. So always when we find the vector product of two vectors, the result will be perpendicular to both A and B. So these are the things which you have to remember when you are taking the cross product or vector product of two vectors. They are defined as AB sine theta, that is the magnitude, plus there will be a direction. Direction you can find with right hand screw rule, that is take a right hand screw, keep it perpendicular to the both vectors and rotate it from the first vector to second vector along their smallest angle. Then the direction in which the right hand screw advance will give you the direction of the product. Or in practice, you can use your right hand, curl your fingers from the first vector to second vector, and then the thumb will point in the direction of the result. And another thing is that A cross B is not equal to B cross A. Therefore, vector multiplication do not obey commutative law. Or vector addition, vector multiplication, if it is scalar, is commutative. If it is vector, it's not commutative. And A cross B is equal to minus of B cross A. And the product, vector product, will always be directed perpendicular to both the vectors. Now let me ask you one thing. When is sine theta 0? When will you get sine theta as equal to 0? What should be the value of theta? What is sine 0? Equal to 0, right? Suppose I take two vectors A and B in the same direction. If A and B are in the same direction, what about their angle? Angle between them will be 0. So sine 0 is 0. You can say that if two vectors are in the same direction, if they are parallel, what about sine 180? What is sine 180? That's also equal to 0. So if two vectors are in the same direction or if they are in the opposite direction, their cross product will be equal to 0. You may be given two vectors and you will be asked to find whether they are parallel to each other or perpendicular to each other. If they are parallel to each other, that means they are in the same direction. Their cross product will be equal to 0. Now, if they are perpendicular to each other, remember A dot B is equal to AB cos theta. And if theta is equal to 90 degree, that is equal to 0. So, if two vectors are parallel to each other, their cross product will be 0. Parallel, then this will imply that the cross product is 0. And if two vectors are perpendicular to each other, they are perpendicular, which means the angle between them is 90, then their dot product will be equal to 0. So if you are asked to find whether two vectors are either parallel or perpendicular, first you go for A dot B. If it is 0, they are perpendicular to each other. If it is not equal to 0, try with A cross B. If it is equal to 0, then they are parallel to each other. Sometimes in the problems, they will tell that two vectors are perpendicular to each other. Find a particular value based on the dot product that you can do. Because you can take A dot B is equal to 0 and then solving few equations, you will get the value of the unknown quantity. Similar is the case with parallel. But before going to that, I would like to explain to you how to find the cross product if instead of the magnitude and angle between them, you are given two vectors in the component form. For example, I have two vectors, vector P is equal to maybe 3i plus 2j minus k. And another vector q is equal to minus 2j plus 3k. Find p cross q. So you have to find p cross q if they are given in the component form. So you can write it as equal to, p cross q is equal to, you can put determinant. Do you remember determinant? Have you learned determinant in math?
Yes.
Yes.
Okay. So you know how to find the determinant. So you can do the determinant. Take I, J, K as the first row. And the second row should be the first vector. See, it is 3, 2, and minus 1. You have to take the magnitude along X, Y, and Z direction. This is 3, this is 2, and here it is minus 1. Now, what is along X direction in Q? Is there any component? No. So, it will be 0, and then minus 2 and 3, and then find the determinant. So when you take the determinant, first you have to put I cap times. You neglect the first row and the first row and the first column. So you get these quantities. So first you will multiply between these two minus multiply between these two. So first you will multiply between these two. So you will get 2 times 3, 6 minus 1 times minus 2, minus 1 times minus 2.
Minus 2.
It's 2. Minus times minus is plus. Okay, here it is minus. So minus 2. Now, when you go for the next row, you have to start with the minus. So you have to take alternate plus and minus. First we took plus. So next we have to take minus. So minus j. Now you are neglecting the second row. Sorry, the first row and the second column. The row and the column containing j, you have to neglect. Now it comes between 3 and 3, this one. 3 times 3 is 9. Then
9.
consider minus 1 times 0 is 0.
0.
So minus 0 plus k. So k cap times. Now when you are taking k cap, neglect the row and column containing k. So this column and this row, and you will be multiplying between these and this. So first this one, 3 into minus 2, minus 6. 2 into 0, 0, minus 0. So you will get here 6 minus 2, 4. So 4i minus 9j minus 6k. So you got ijk when you found the dot product using the component form. You didn't get ijk there, right? Because it is a scalar quantity. It's just a number. But when you find the cross product between two vectors, you will get another vector. Now, how to find the magnitude of this vector? How to find the magnitude of P cross Q? P cross Q is equal to root over 4 square plus minus 9 square plus minus 6 square. So this is equal to root over 16 plus 18 plus 36. You can find it out. So this is how you can find the magnitude, and how to find the direction. You can find the unit vector, that is the vector itself divided by the magnitude. So that is how you will find the magnitude and direction of cross product between two vectors if they are given in the component form. Now, what is the relevance of finding cross product? What is the meaning of cross product between two vectors? Suppose you have these two vectors A and B. A and B are there. Vector A and vector B. Okay, and the angle between them is theta. Just as we considered before for dot product, let me consider perpendicular drawn from the head of B to A. And let me mark these points as O, C, and D. Right? O, C, and D. Now, when I take the sine theta, we have here sine theta, right? So when I take sine theta is equal to opposite side by hypotenuse. When I consider this triangle, opposite side is CD divided by hypotenuse is the magnitude of B. Okay, so when I substitute to this magnitude, A cross B will be equal to A B, instead of sine theta, I am writing CD divided by B. So I will get it as A multiplied by CD. I got it as A multiplied by this height. Now suppose these two sides are two sides of a parallelogram. Suppose I have this vector A and this vector B, and they are two sides of a parallelogram. Okay, what is this length into height? What is one side of the parallelogram into height of the parallelogram? What is that? One side into height. One side into height of a parallelogram is the area.
Area.
Side times height is the area. So if A and B, two vectors forms the two sides or adjacent sides of a parallelogram, if you find the cross product, you will find the area of a parallelogram. This is equal to area of a parallelogram. So if two vectors form two sides of a parallelogram, you can just find their cross product, you will get the area of a parallelogram. And remember, in physics, sometimes we consider area as a vector. Now, if you want to find the area, the value, the magnitude, find the cross product and then find the magnitude. That will give you the area of the parallelogram. Now, there is one more thing. What is the area of a triangle? What is the area of a triangle?
Half into base into height.
Triangle area is equal to half into base into height. Right? So suppose I have a triangle here. And this is the base. This is the height. Right? Now suppose these two sides, two adjacent sides of a triangle forms two vectors. Two adjacent sides of a triangle forms two vectors. Then if this is A and this is B, A cross B is equal to A into CD, right? A means base into height. So you can tell that half into A cross B will give you the area of a triangle. So you can put that this is equal to area of the parallelogram, or area of a triangle is equal to half into A cross B, its magnitude. So if you have two vectors forming two adjacent sides of a triangle, you can take their cross product and take half of it, you will get the area of the triangle. Just taking the cross product, you will get the area of the parallelogram. Is that two concepts clear to you?
Yes, teacher.
So whenever you have a triangle or a parallelogram with adjacent sides as vectors, you can find their area by finding the cross product between them. Now let me consider in physics, where are the areas where cross products come? Can you tell me one example in physics where cross product comes? Where do you find cross product? When you multiply two vector physical quantities, the result also will be a vector. Do you remember torque? Torque. Torque is represented by the symbol tau. What is torque?
Teacher,
Torque,
the actual will.
yes.
It is the vector product of radius and force.
Yes, it is the vector product of radius or the perpendicular distance and force, R cross F. For example, when we apply force on a body, it will move. Suppose I have this pen here, and if I apply force on the body, it will move, right? Now, if I have this quantity in this pen here, one of the end is fixed. If I apply force only on one direction, what will happen? It will not move as a whole, but it will rotate. It will rotate. So what causes the translation motion? That is, the full body is moving. That is force. Now what causes rotation of a body? That is called torque. So when you consider torque, suppose I am giving 2 Newton force here. And this distance is r. So the perpendicular distance and the cross product of force and perpendicular distance, if you take the cross product, you will get torque, which is also a vector. So you have to take the cross product of r and f to get torque. Another example, have you learned angular momentum? What is angular momentum? Angular momentum represented by vector L. Angular momentum L is equal to?
R cross P.
Yes, R cross P, where R is the perpendicular distance or the radius and P is the momentum, linear momentum, mass into velocity. So here again, see, when we find momentum P as equal to mass into velocity, here you are multiplying a scalar quantity with the vector quantity. Now, when you are finding the angular momentum, radius is a vector which is directed whenever a body is moving in a circle. This is the radius vector. And if it is moving in this direction, momentum will have the direction of velocity. So it will be tangential, and angular momentum will be R cross P, right? So when you consider R cross P, it will be perpendicular to both the radius vector and the momentum. So suppose I want to take, this is a free vector, so I can draw it anywhere, the radius. So I'm putting R here. So this is momentum P. So this is the angle between them, theta. So if I consider R cross P, I can take it from here to here. See, what is the direction of angular momentum? Outwards. It's perpendicular to both the radius vector and the momentum P vector, and it is pointed outwards. Okay, so outwards means it's along the axis. It's perpendicular to the plane of rotation, that is perpendicular to both radius and P. Now, another thing which is of interest when we consider the cross product of two vectors, what are the cross products of the unit vectors? Unit vectors in x, y, and z direction. So let me draw the coordinates here. X, y, and z. Okay. So I, j, and k. What is I cross I? What will be I cross I?
0.
0. Why? I and I are in the same direction, parallel vectors. So the cross product will be 0. I and I, the angle between them is 0. Sine 0 is 0. So this is equal to 0. So is the case with J cross J will be 0 and K cross K will be equal to 0. Now let us consider I cross J. I cross J equal to. So they have magnitude 1 into 1. So the magnitude will be 1. Let's look at the direction. I'm taking my right hand and I have to hold it in the direction of I, curl it towards J. So it's outside, means along the Z direction and along K. So it has unit K, unit 1, magnitude 1, and it's along Z direction. So I can represent it as a unit vector J. Yeah, sorry, K. So I cross J will give you K. So similarly, what will be J cross K? Z direction is outwards, right? So I will start from okay, I have to put my fingers in the direction of J and cross it towards outside because Z is coming out of the board. So when I curl it towards outside, my thumb is pointing in the X direction. So it will be unit vector in the X direction, which is I. Got it? Is that clear to you? Okay, now what's remaining? K cross I. K cross I is equal to, so I have to start from outwards. I'm holding my fingers outwards and I'm pointing towards, curling it towards the x-axis. See, my thumb is pointing up, which means along the y direction. So unit vector along y direction. So I cross J is K, J cross K is I, K cross I is J. Now let us just switch it. What will be J cross I? Without checking, can you tell me what will be J cross K I?
K.
I cross J is K. So J cross I will be, we know that A cross B is not equal to B cross A. What is A cross B equal to? Minus of B cross A, right? Let us check. So J cross I. So I have to take my fingers in the direction of J and curl it towards X. See, my thumb is pointing into the whiteboard, Out of the whiteboard is Z. So into the whiteboard is minus Z. So it's minus K, not K. So J cross I is minus K. Remember, A cross B is not equal to B cross A. It's minus, so it's negative of K. Similarly, if I switch this, K cross J, it will be equal to, can you tell me what will be K cross J?
Minus I.
Yes. And what will be I cross K?
minus J.
Minus J. Or to remember this, you just remember the cycle. I, J, K. If it is taken in the cyclic order, I, J, K, if it is I cross J, for example, see, if it is I cross J, it is K. If it is J cross K, it is I. If it is K cross I, it is J. If you go in the cyclic order, you will get positive quantities. Okay. Now, if you go in the reverse order, you will get negative quantities. So, suppose I take I cross K. I have gone in the reverse order. So, it will be minus J. K cross J, gone in the reverse order, minus I. J cross I, gone in the reverse order, minus K. So is that clear to you? Just remember that I, J, K, if you're going in that order, you will get positive quantities. And if it is in the opposite order, you will get negative quantities. So this is what I wanted to discuss regarding the cross products. And next class, we will start vector calculus.